Hey everyone, and welcome to the next weekly edition of the Daily Coding Challenge, where I will pick a random hard problem off of LeetCode and I will solve it live. Let's start off with a hard problem, and we're going to sort by acceptance rate, just so we get something that's not too esoteric. So in the very first edition, I believe we did number of flips. The next one we did was build array where you can find exactly k comparisons. And it looks like there's one here that I haven't seen before. Reducing dishes. Maybe it's a new one, because it wasn't there the last time I checked. Let's take a look. I personally hate cooking. I do not cook at all, so I do not have any way of relating to this problem. But that's how most interview problems are, aren't they? It's never something you can relate to. This almost seems like an efficiency metric. How do you maximize the amount of satisfaction you get while at the same time minimizing your time spent? Okay. The maximum coefficient, you're basically trying to maximize your efficiency. Okay. And dishes can be prepared in any order, and you can even discard some dishes to get this maximum value. All right. And it looks like you have negative satisfactions as well. That's very realistic. I've suddenly eaten dishes that I have regretted eating afterwards. Oh, okay. So all dishes take the same amount of time, 1 unit of time. Okay. This seems odd. Why would you spend time cooking the dish that's getting you a negative satisfaction? And even the one that gives you zero satisfaction. It seems like if you just cook this one alone, you get an output of 15, right? What am I missing here? Oh, interesting. So the time is not the time taken to cook that dish, it's the time taken to cook all dishes. Huh. That is a very weird twist. So this one, this example, you actually want to cook a dish that is not satisfactory, just so you can increase this number further, make it a 3 instead of a 2, and that gives you 5 times 3, 15. Yeah, because if you just cook this one dish alone, it would just be 5 times 1, 5. Huh. Interesting. Okay. So my first thought was that you always want to put the highest one last, because then it benefits from the biggest multiplier. But they're saying in this one, dishes can be prepared in any order. Is that actually true? Like if you cook this one first, followed by this one, followed by this one, you would get 4 plus 3 times 2 plus 2 times 3. That's 6 plus 4, 10 plus 6, 16. Okay, so they're not actually saying you can do any order here. They're saying to get the maximum score, you have to do it in this order. Okay, got it. In this example, they don't like any of the dishes, just don't make anything. And for this one, they just refuse to even give you the reason. They're just saying this is the answer. Alright. Interesting. Alright, let's first set up some packages here, shall we? New package. Let's call this dish satisfaction. Alright, the first thing I'm gonna do is just set up the 4 examples they gave. Give my mind some time to think through this problem in the background. Alright. So this is for the test. Now let's create a new package for the actual code itself. Dish satisfaction. Solver. And so the input is just a list of integer. Let's call it dish satisfaction. And it produces an int. Alright. I forgot if Java allows for primitive int var args. Let's find out. I don't want of, I want a copy of. Will this work if I do an integer? Yeah, that works. There we go. So, we're gonna do the boring part of just setting up the test first, because that will definitely be of help to us. Alright, the very first implementation, let's be a very lazy chef that always does nothing. And we will run these tests. This one, the lazy chef actually wins in example 3, but he should fail in all the other examples. And yeah, alright. So the test is set up correctly. It compiled and it ran, that's great. My first thought is that you definitely want to make the most satisfactory dish last, because that's when you get the biggest payout from the biggest multiplier. And I'm see no reason to doubt that so far. So I'm gonna stick with that. Reformat code. All right. The first thing I'm gonna do is to make a copy. I believe it's collections dot sort. Yeah. So the reason I can't just sort the input directly is because, well, in my case, I'm creating an immutable list, so you can't sort an immutable list. But more importantly, you generally don't want to uh, modify the inputs that are given to you, so it's better to make a defensive copy for that reason. Just in case the caller is doing something weird, like expecting you to not modify it or modifying it on the fly while you're doing your thing dynamically. So, make a defensive copy. That's generally a better thing to do. Okay. So really what it comes down to is that, once you've sorted it, you definitely want to make the most satisfying dish last, because that will give you the biggest multiplier. You want to make the second most satisfying dish second to last, because that will give you the second biggest multiplier, and so on. So really what this comes down to is, for every single element in the list, you basically just have one question to ask yourself. Do I want to make this dish, or do I want to not make this dish? If you make this dish, then you include it. If you don't make this dish, then you do not include it. And one problem with that approach is that if you have n elements in your array, it's going to take 2 to the power of n time to go through all those combinations. Because each element is going to have a binary choice, so 2 to the power of n, 1 for each element. So 2 to the power of n processing is generally never a good thing. But there are some heuristics we can take. If we know that a number is positive, then we will always want to include it. There's never a case when you don't want to include an element that is positive. Because if it's positive, it's going to increase your satisfaction score. It's going to increase your immediate satisfaction, and B, it's also going to increase the satisfaction of any element that come afterwards. So the only time you really face this conundrum is when you're dealing with a number that is negative, because that's when you have this choice. If it's negative, it reduces your score immediately, but it will boost your score further down the road because the multiplier becomes bigger. When I say multiplier, I'm talking about this, times 3. The time taken to cook the dish, including previous dishes. So a negative dish will reduce your immediate satisfaction, but it improves your long-term satisfaction. So that's the approach we can take here. And in fact, to make that work better, what I'm going to do is to create a helper, which is time spent thus far. First thing we're going to do is there a sort? Java is sorted. Checking if a list is sorted. So usually you can do this in order n time, so it shouldn't be a very expensive operation. Guava. Guava has everything, guys. Always use guava. So ordering dot is sorted. Natural. Okay. Strictly ordered. The reason I'm rabbit holing here is that I forgot what the placeholder is supposed to be. Okay, I think it's percentage %s. Alright. So we'll go with that. Alright, so now we've set up the recursive call, validated that it's sorted. And the reason I'm using a linked list here is because with a linked list you can remove the very first element in 0 time. So that makes it much, much easier. Otherwise with a array list it actually takes order n time to just remove the first element. And to do remove validation if trying to improve performance. And the reason I put the comment is because checking for is ordered will take order n time. So, you know, that's not a deal breaker, but it could be optimized further. Alright, we set up the termination condition. If it's empty, return 0. And at this point you will always have a element if cur is greater than or equal to 0. Okay, so the current element is greater than or equal to 0. It's very easy. You just take whatever points you scored thus far, and then you add I actually don't need this point scored so far. Yeah, I'm gonna do it over here. So the very first one, you come in here with 0 time spent so far, but then you have to include the time spent preparing that dish. Yeah, time taken to cook that dish, including previous dishes. So it's time spent so far, plus 1 for the current dish, multiply by the current dish score, and then you add the max satisfaction that you get from the children. Alright, so if it is negative, that's when you got to do the fork. And in this case, the fork would be, if you take it, I think this is going to work. So the idea is that if your dish is empty, you just return 0. Next thing you do is that you remove the first element. I think you always want to remove the first element because um, whether you decide to cook it or whether you decide to not cook it, the subsequent child call shouldn't have that element. So you always remove it. You never put it back or anything. You just remove it. And next you ask yourself, if I cook this dish, what's my score going to be? So if that's the case, you take your current value and then you add whatever value you get from the children, from the downstream effects of, the list without the element, and you'd now spend 1 additional time. And if the current value is greater than or equal to 0, this is always what you return. If the current value is negative, then what you would do is that you just you consider, okay, what if I don't cook the dish? In which case you want to get the satisfaction from the remaining elements in the list, but the time spent so far hasn't changed. It's the same as what it is right now. And then you just return the maximum of these two options. All right, let's run this and see what happens. Interesting. I got the more harder ones, but I failed the easiest one. Oh, that's why. Oh, it is -9. Oh, what did I do wrong here? Alright, step through this. Well, actually, you know what? Let's assume this is an interview problem and I don't have my IDE available to me. So this is actually very useful already. I know what the expected answer, I know what the actual answer that it produced is. Um, it's just making sure that the way this sorting works is that it's sorting with the smallest elements on the left, the biggest elements on the right. And that does seem to be the case. Huh. Alright, so let's work backwards here. Let's go to the very terminal case where you have 5. Well, let's start with the very first one. That might be easier. So you're going to have -9, -8, -1, 0, 5. So you go to -9. You do the validation, you remove the -9. One times -9 plus satisfaction, or just do the max satisfaction of times spent so far. Okay, so I believe this will be higher, but let's go down. So you go to -8, the same thing happens. You go to -1, and so now you've done 1 times -1 plus max satisfaction. Alright. I'm at the end of my caboose here. Time to just step through a debugger. This is very odd. An example of 2, 3, and 4 all return the correct answer, but not this one. Deadline took a surprisingly long amount of time. Alright, so validated that these sizes are correct. So I already got a 6 here. This is not right. If you don't cook the dish, you're definitely not going to end up with a -8. Let's go to the terminal case and we'll work our way up from there. Alright, so now we got to 0, 5. Okay. So far so good. Let's go with dish cooked as 25. Okay, that sounds right. Score with dish cooked as 22. Okay. Okay, so for the 9, you don't want to take it. Okay. So now you go to score without dish cooked. For that you have 0 time spent so far. Oh, I see. God damn. God. I see what's going on. I made a very rookie mistake, and boy do I feel silly. Essentially, the first time around you go all the way deep, you remove all your elements, and then you come back to the top and there's nothing to put back in. Well, that's pretty silly now, isn't it? Yeah, the first time you go all the way down the stack, you've removed all the elements. So now when you come back here and you do max satisfaction, well, guess what? Your dissatisfaction isn't just the first element removed, it's all elements removed, because you've gone down the stack and removed everything. Well, let this be a very important lesson for everyone. Make your thing immutable. Alright. So now, Alright, so the new approach that I'm going to go with is that I'm not going to remove elements, because as we saw, removing elements is very, very dangerous. Instead, I'm going to use a input to the method to keep track of where I'm at in the list so far. So this way you don't have to worry about manipulating data. This is a very good programming lesson for both me and for everyone else. Where possible, make your inputs immutable, make your data structures immutable. So this way you don't have to run into the kind of weird pitfalls that I just ran into. So if the size is greater than or equal to starting dish, return 0. Okay. And instead of doing a remove, I'm going to do a get. And that was another silly mistake of me. Dot get starting dish. There we go. Alright, let's give this a try. And there we go, guys. Everything finished quick and easy. Took apparently 0 milliseconds to run the other tests, and just 97 to run the very first one. Alright, there we go. Now what I'd like to do is to actually look at the submissions that people have had and compare it to mine to see if there's a better way of doing this problem. And there is no better way. I guess it's a brand new question. That's why there's no better way. No one else submitted anything. So this is a fun thing that I haven't done before. Why don't we submit our solution? Oh, I see. So now that there are no submissions, there's only my submissions. Here is the discussion. Sort by most votes. Easy and concise. Alright, I like the sound of that. Yeah, so this is the key inside that we have also used. Wow, this seems a lot simpler than what I have. Let's see what they're doing. So they sorted it. Let's all read it as well. Okay, so they're actually starting from the rightmost side and then going left. That's interesting. Huh. That's really smart, actually. I'm gonna make a note of this. Interesting, okay. So I guess here's what the key insight is here. Imagine if, for example, let's go back to the first example that we had here. 18059. So let's say you start off with the rightmost, you have 5, then you go to the next one and you have 0. Or let's say it was 1, for example. Every time you add a new dish, you're also increasing the score of the dishes that you've selected already. And the key insight here is that the amount you're increasing it by is equal to the sum of the dishes you've selected so far. So for example, if you've selected a dish that's 5 and then another dish that's 2, now it could be 2 times 2 plus 5 times 3. Write this down. So let's say, for example, you have something like, -1, 2, 5. So you start off by just selecting 5, and then you end up with 5 times 1. Now, when you select the 2, this becomes 2 times 1 plus 5 times 2. And then when you pick the third one, you've gone from -1 plus 2 times 2 plus 5 times 3. The key insight here is that this 5 times 1, it goes from 5 times 1 to 5 times 2. So the delta here is plus 5. Now over here, you went from 2 times 1 the more general way of looking at this is that every time you add a new element, obviously the previous score remains the same, but you also do a sum of all previous elements because you went from initially at 5 and then you added another 5 because it became times 2. Now over here you added another 2 and then you also added another 5. So you basically do the sum of all previous elements. And that's why the key insight here is as long as the current element is greater than the inverse, the minus of the previous elements, because when you add a new element, you're getting new total. So as long as the current element is not more negative than the total you're adding, you want to keep adding it. Yeah, and what you add is basically the total, which is, the previous elements you have so far, including the new one, and then you just add it. Huh. So there you go, guys. I think the solution that I have would work in a more general sense. I don't know if there's any situation where my solution is better, but it does work. My solution is basically doing a recursive search of all possible options with some heuristics saying, if your element is greater than or equal to 0, you always want to choose it. Otherwise, you do a recursive search of both taking it, not taking it, and you compare the scores. Whereas this solution is definitely much more efficient. It makes use of a very nice mathematical property that allows you to determine immediately, without doing any sort of recursive search, whether or not you want to include the element. So in that way, instead of ending up with the worst case to the power n solution, you end up with a very well-performing n log n solution. So whoever came up with that, I think his name was Lee215, kudos to you. That is definitely a better way of doing it. But anyway, I hope you guys enjoyed this video, and I enjoyed making it for you guys. See you next time.